It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about continuity of a function of an interval with a radical function. Let's try to determine if the function is continuous at the given interval, close interval -3, 3, with your f of x equal to square root of 9 minus x squared. So since the first condition here, because this is closed interval, first condition that we need to meet is we are to check if f is continuous at interval, open interval, -3, 3. So checking that one way of checking it very quickly, because if you are going to check it like getting numbers in between -3 and 3, you will not be finishing that one quickly, because there are plenty of numbers that are in between -3 and 3, not only -2, -1, 0, 1. We do have a number in between them, so that's a lot. So one way of checking whether we've got a number within the interval that makes it problematic. Why problematic? Because once we say square root of a number, it must be that this radicand, or the number inside, must not be equal to a negative number, because the square root of a negative number, let's say -1, that is I, or imaginary, meaning it does not exist. It only exists in our imagination. So we avoid having our number inside a radical symbol as a negative. So that is why we have to check. How do we check that one? We have 9 minus x squared. We wanted to check what will be the possible value of our x that will make our 9 minus x squared not a negative number. So we have to check the condition here by simply having it as greater than or equal to a 0, meaning to say the entire 9 minus x squared will be greater than 0, meaning positive numbers, or equal to 0, meaning it could be that the entire thing would result to a 0. Those are the only allowable value on the radicand, or the values inside the radical symbol. So let's try to solve for x. Now, what is the value of x? We are going to move 9 to the other side. So we have -x squared. That's greater than or equal to -9. We are to get rid of the negative sign here. We divide this by -1, and so with this one. Our x squared here, since we're dividing negative number, we're changing the sign here of our symbol. That means this is now less than or equal to +9. Then we get our square root of that one, which is x less than or equal to +3, meaning to say our x value is less than or equal to 3, or x is less than or equal to -3. So let's try to check. Now let's try to know what are those values that are within this set of values of x, or the domain. So it says here x must be less than 3. So if this is 3, that means to say we're considering numbers such as 2, 1, 0, 1, to -1, -2, -3, -4, and so on. We do include our 3 here. Now, x being less than or equal to -3 would mean that this one is also included, and the rest of this. So if we are going to consider what are the possible values of x that we wanted to take, everything that is located on the left side of 3 are okay. So let's go back. The interval here is we have negative 3. That's not included because we have open. We have negative 2. We have negative 1, 0, 1, 2, and then 3. This is also not included. So if you try to check on the numbers here, we don't have a number that is below negative 3. I mean greater than negative positive 3. So every numbers in between the interval will satisfy this one here. So that means f is continuous at that open interval. So since that is satisfied, we are going to move for b. b here we need to check with our limit of f of x as x approaches our a here is negative 3. Negative 3 coming from the right side. Why right side? Because if we want to find the limit as your x approaches negative 3, the only numbers that are approaching negative 3 here is coming from the right side. We don't have an approaching value on negative 3 from the left side. We will be checking whether that is equal to f of negative 3. So let's first find limit of f of x, which is square root of 9 minus x squared as x approaches negative 3 coming from the right side. So coming from the right side, the values of your negative 3 are the following. We have negative 2, negative 1, 0, 1, 2, and 3. We don't have a problem at all. That is why we're trying to substitute that value to our x. 9 minus negative 3 squared, that will be equal to square root of 9 minus 9, which is equal to the square root of 0, which is a 0. So that is our limit. Let's try to check our f of negative 3. f of negative 3 is equal to, we have square root of 9 minus negative 3 squared. That will be equal to square root of 9 minus 9. That's equal to square root of 0. That's equal to a 0. Our 0 is equal to a 0, so this is met. So we go for our c. We need to check whether our c is met as well. At the limit of f of x as your x approaches the other value on the other number on the interval, which is 3. This time, since we are approaching 3, that will be coming from the left side if that is equal to f of 3. So we have here limit of square root of 9 minus x squared as x approaches 3 coming from the left side. 3 coming from the left side, we don't have really a problem with that one because we have negative 2 that is also part of this. So all we have to do is to just simply plug in. We have 9 minus x squared. X is 3, squaring that one. We have square root of 9 minus 9, and that is square root of 0 or a 0. Let's try to check on f of 3. f of 3, oops, that will be equal to square root of 9 minus x squared. This is equal to square root of 9 minus 3 squared. That's equal to square root of 9 minus 9, and that's equal to a 0. Since these two are equal, that means to say that this one is equal or satisfied. The c there is satisfied. So therefore, we have now our conclusion that our f of x is continuous at negative 3, 3. So let us now go for this one here. We have square root of x plus 5. We are to check first because this is half closed. We have to satisfy our a first, that whether f is continuous at negative 5, 1. So upon checking that one, we have x plus 5 as the radicand. So we have x plus 5. This must be greater than or equal to 0. Moving 5 to the other side, x is greater than or equal to negative 5. So we need to say, if we consider our values of x, if this is negative 5, this is pointing towards the right side. So we need to say, we are considering negative 4, negative 3, negative 2, negative 1, and so with 0 as part of the domain of our radical function. So checking up on the interval, we have negative 4, negative 3, negative 2, negative 1, 0, and then so with the numbers in between them, they are allowed numbers, so automatic this is satisfied. Let's go to B. Since this is closed, half closed interval, we are only checking whether limit of f of x as your x approaches 1 coming from the left side is equal to our limit, not limit, but our f of 1. So this is now limit of square root of x plus 5 as your x approaches 1 coming from the left side. That will be equal to 1 square root of 1 plus 5. That will be equal to square root of 6. Let's now go for f of 1. F of 1 here is equal to square root of x plus 5. That will be 1 plus 5 equal to square root of 6. They are equal, so that means this one is satisfied. Our function f is said to be continuous at the interval negative 5, 1. So that is how you are going to check on continuity of radical functions. This is once again your teacher Jenny saying practice and practice, and that will make you perfect someday.